Hello. Yeah, very good evening, good afternoon. Yeah, how are you? Okay, so let's proceed towards the NumPy. I had already started with the library of NumPy. Can you hear me well? Yeah, students, can you hear me well? Okay, okay. Fine, so let's start. Here, we are already started with a very important data science library. That one is a NumPy here. NumPy stands for, can you tell me NumPy stands for what? Can you come here into the query portal? You can write what is the full form of NumPy. Yes. Tell me what is the full form of NumPy? Very good. Yeah, good. Any other? Thank you for your responses. You can interact with me into the query portal. So that one is a NumPy. NumPy stands for Numerical Python. Numerical Python is basically one of the very important data science library, which is going to work on multi-dimensional array. It can be working on 1 or a 2D array. Arrays, I had told you what are arrays. Arrays are the central data structures within the NumPy libraries. And arrays are the collection of items stored into the contiguous memory allocations. And they are identified with the help of their indexes. With the help of arrays, we can do our work very easily. The processing of any of the data are very fast into the memory. So numerical NumPy, yeah, hello. So NumPy basically works on these arrays. We had already started with all the commands of the NumPy. So you tell me, if I want to work with NumPy, which library I will be calling. You come here and interact with me into the query portal. Which library I need to call if I want to work with the NumPy? Which library I need to call with the NumPy? Okay, good. Okay, we are doing a NumPy. Exactly, import NumPy. We have to do import NumPy. We have to do. Okay, good. Thank you. Import NumPy, already you know. We are going to do it here. We can make any NumPy array, np.array. Already I did it a lot of work yesterday, but I'm just revising a little bit only. So here I can make the NumPy array and you can see the values of A. Hey, here, if I want to write a dot shape, so here it will be giving the shape as 4 elements because this is a one-dimensional data here. So one vector array it is there. A dot ndim will be showing number of dimensions, that there is a one-dimensional only. Now, if I want to find out a dot size, so here it will be giving me 4. 4 means here it is giving me that there are 4 elements. 4 elements means 1, 2, 3, 4. 4 elements are there. Okay, like earlier I told you. At the same time, if I increase this 5 or 6 or 7, so if I run it, run, 7 elements are there. One dimension and the size is 7. It means 7 elements are there. Can you guess here, student, if I'm writing here a dot d type, what should it give? If I'm writing here, what is the data type by default? What should it give? Just to guess only, your assumptions are required. You guess if I write a dot d type, what will be the answer? What is the data type going on? What is very good? Good answers. I'm getting a very good answers. Very good. Some more answer I need. Only few students has responded. What is the data type? Default data type it is. Right answers. Correct. Correct. Thank you for your answers. So the data types are integer 32. Integer 32 means, can you tell me integer 32 have how many bytes? It means each element is occupying how many bytes? How many bytes? B-Y-T-E-S. Integer 32 means how many bytes? How many bytes? Right, I'm getting right answers. Those who are giving me answer, thanks for them. I need more answers. That integer 32, it means how many bytes are there? Very good. Very good. So that one is 4 bytes. Integer 32 means 4 bytes because 8-bit represent, just wait here, like 8-bit, 32 means 32-bit. 8-bit represent 1 byte. So 32-bit means 4 bytes. You simply divide 32 by 8, that means 4 bytes. So it means each of this number, they will be taking 4 bytes to store inside the memory. Okay. Now you think, suppose here I'm writing a dot item size. What will be the answer? Think it. How much memory it is going to take with a single number? Think it. Okay. So that one is what? Good. So that one is item size means 4 bytes. 4 bytes is going to take it. So whenever we are writing here a.numpy array, by default, the data type is there integer 32. Though I had did all these things yesterday, but just a revision, I'm doing it here. That's all. Integer 32 it is by default. Even you write it or won't write it, does not matter. It is a default working here. Default is working here. And it is just saying 4 bytes. Now here you can see, yeah, now you can see here, integer, suppose here right now default is an integer 32. If I want to increase the number of bytes, so I can give here integer 64. Integer 64. So integer 64, if I'm running it here, what will happen? My size and the data type will be changed. It means here, integer 64 will be the data type and the item size will be 8. This is 8 here, 8 number of item sizes there, because I had just given integer 64 here. So integer 64 means I'm just increasing the number of byte to each element. So suppose this is the element, it is going to take integer 64. 64 means 64 bit it is going to take. And if you divide it by 8, so you'll be getting 8 bytes. So it means this 5 number, it is going to take 8 bytes to allocate onto the memory. So basically, it means we are increasing the size of the memory. But it is best to give the default size. That one is integer 32. So it is better to remain with the default one here because it consumes less memory. So here we'll be giving integer 32. So item size is 4 here. The minimum size is a.min. I had told you that minimum is 1. So what is the minimum number? 1 is the minimum number. At the same time, a.max is there. So maximum is, what is the maximum number? That one is 7 number. So here it will be giving you 7. Got the point here? So this one is this a.minimum and a.maximum. It is giving into the one-dimensional array. In the similar way, I had already created a two-dimensional array. I had shown how to create a two-dimensional array. Integer 64 option, it is better not to use, I'll tell you, because you are just increasing the memory and it will occupy your more memory. So we should stay with the default integer 32. Yeah, integer 64 is generally utilized in float data. Float data means here, whenever I'm taking the decimal values there, it will be taking integer 64 almost by default. Okay, so just wait. I'll just do certain more work and then just answering some more of your questions here. Wait. So here I told you how to put this data to two-dimensional data. Also, I had shown you yesterday all these things I did it, but still I'm doing it a little bit only a refreshing. B dot shape. So here it is going to show you 2 rows, 2 columns. B dot ending. The number of dimensions are 2 because we are having the X and Y. B dot minimum is basically, no, it is minimum value. So here it is just giving minimum number is 1. B dot maximum is going to give you the maximum number. That one is a 4 here. So this one is a two-dimensional array data. Here also, if I want to check it out, B dot D type here, if I want to check it out, B dot D type. So this one is integer 32 default. Okay. Now here, so it means we can just put here integer 32 here. We can just put here D type default here as an integer 32. So these are the default working here. Okay. So that is there. So even if I run it, so that will be started taking here integer 32. That is a comma actually, comma. So this one is there. Now it is integer 32. Already it is integer 32. Okay. Now here, suppose I'm taking one of the numpy array, np dot array. And here I'm making any numpy array. Suppose I say 11.2, 34.5, 67.2. Okay, this value, any value you can just put it. This one is there. C dot shape, if you are checking out this one. But here, let's check it out. C dot D type here. C dot D type, we can see it here. It is not required to specify the data type. We are not requiring to specify any data type. But here, for the justification, we are looking here that what is the default data type here. So default is integer 32. Even you gave it, does not matter. So this one is D type, float 64. So what is happening by default? This one data is a float data because numerical Python works on integral data, means either integers or float data. So by default, float data will be taking 64. 8 bytes it will be taking, because some of the bytes it is consuming for 4 bytes it is consuming for this data before decimal, and rest of the bytes 4 bytes it is consuming for the after decimal values. So here, even by default, what happens? The same float 64 is represented inside the binary data. Default it is even here float 64. That is the default. So remember, float 64 is default in floating data. But in integer, it takes default as a 32 because it consumes 4 bytes for each integer. We should not change this figure to 64 because it is just wasting the memory, because in memory, we have to take care that we should precise the memory. We should not give extra memory to the data actually. We should secure the memory. So here, that's why 32 is more than sufficient. We should not give here 64, but in float data default is 64 because 4 bytes given to before decimal, 4 bytes are given to after decimal part here. Okay, we are not requiring to write these float or any of the data type not. These are the default one here. Even we won't write it here, so that will be working. Okay, here, suppose here I'm writing D is equal to NP dot array. And here I'm making the array. Just wait here. See, here I'm just putting any data, 12.3, 45.3, 5.3, wait. It is a 45. Here I'm just giving 56.2, 78. 0.2, any data you can put it here. If this is there, so this is a 2-dimensional array data. Here you can take any shape, that is your choice here. 2 rows, 2 columns, it is here. So still, if I'm just checking it out, wait, D dot D type here, I'm just checking it out, float 64, it is by default. Okay, so this one's the default working. At the same time, what I do, if I'm just changing here D type, see, though I'm putting the data with a decimal point here, but here I'm just change the data, whatever data I'm providing, that one in decimal format, but I need the data in integer format. So let's check it out. See here, though I'm putting the data in this decimal format, float data, but here I recommended, okay, the data type should be integer 32. So you can see now that entire data which is coming in float data, that one is converted into the integers actually. So decimals values are gone away here. No, do not use float 32 because float 32 is not required because some of the bytes will go to before decimal and after decimal. So it takes 4 bytes before and after. So float 32 is not the right way. So here we will be taking the default float 64. Okay, that much memories are required here, float 64. Okay, so in this way we can see this. Even if I'm doing here, suppose E is equal to NP dot array, I'm putting it here. And here I'm just making any data, let's say 23.4, 56.7, 89.2, any data, I'm just taking 43.8, any data here I'm taking. And here I'm just running this E numpy array, and if I'm checking out the data, it is of course that one is a float here, E dot D type, it will be showing you float 64. Default, it is going to show you float 64 here. Okay. After that, still now, see, though if I want to write here, the data type should be, wait, the data type should be integer 32. So here it will be showing you entire data with the integer 32. The decimal values are waived off. Okay. Now see here, suppose I'm making any other data, suppose f numpy array, I'm making np dot array, and here I'm making a data with decimal values. Okay. This data is default, let's say. Okay, decimal values it is just giving. But what I'll do here, I'm just omitting, I'm just removing these values. Just wait, please. Let me run it. I just changed it. Certain decimal values are removed here. See what it is taking, because it has detected that this value is float. This f numpy array has detected that this value is float, so automatically it is just doing all the values as a float. So what I can do, even I can write here, d type is equal to float. See here, even you write or won't write, it will be taking the data in float only. Float means automatically what it will do, it will be taking, considering all the integral values also in float. You can see here decimal values are default added. Even you gave it or won't give it here, because f numpy array has detected that 56.8 is there. So we'll be taking all the data into the float data. Okay. Okay, fine. So these are the very general basics of numpy arrays there. Okay. Now inside NumPy, there is one of the method, range method here. So let me check it out. Wait, just wait here. Like if you remember in your Python, you did a range function. Range will give a sequence of integers. In a similar way, in NumPy, we are having a arrange function, which will be giving sequence of integers. Okay. So 5, if I'm giving it here, it is just giving 0 to 4, 0, 1, 2, 3, 4. Okay. So 0 to 9, you can see. So numpy.arrange is giving you a sequence of integer. Done. Now, np dot, suppose here, okay. So what we can do, that I can build up a series of number with the arrange function. So suppose here I'm saying np.arrange 12. So 12 numbers will be covered here. 12 series of 12 numbers will be provided. Okay. Now here, if I want to arrange this np.arrange, and here I'm taking 12 number series here, 12. And then I want to apply that one into the NumPy array. So what I can do, there is a reshape method. Reshape method, I can just apply this reshape method as a I can give here a shape of a numpy. Suppose here 12 elements are there, so I can give 3, 4. 3, 4 means 3 rows, 4 columns. It means just generate all 12 numbers and reshape into 3, 4 also. It reshape into 3 rows, 4 columns. So here it is just reshaping into 3 into 4 columns. Got the point here? 3 into 3 comma 3 rows, 4 columns. So what is happening here? 12 numbers I had generated with the help of numpy.arrange, and with the reshape here, 3 rows, 4 columns. So here row number 1, row number 2, row number 3 is there, and 4 column. Column 1, column 2, column 3, column 4. Okay, so in this way we can reshape it here. See here, yeah, it is shaping it in sequence order, no? It needs some, see, just to create a numpy array, we need some data, so we can ask numpy.arrange function to arrange the data, to find out the functions, to arrange the data actually, so that we can find it out here. Okay, let's say, suppose, see one more thing here. Right now I had given a shape of 3 rows, 4 columns. I can change this shape here. I'm taking the same shape here. I can just give here, give me the shape of 4 rows, 3 columns. Now here it is giving me the shape of 4 rows, 3 columns. Means you have to identify the number which you are generating here now. That should be having, whenever you're giving a shape, that should be having a factor actually. Well, the point, the number should be adjusted in any of the factors actually. So suppose here, if I'm generating a data, np dot, suppose here I'm saying 15. Okay. So of course, 15 is the sequence of 15 numbers will be arranged there, right? 0 to 14 means 15 numbers are generated here. Then here I can make this data reshaped. If I want to use this data reshaped here, so here I can take reshape. I need to generate rows and columns with the factors of 15. You need to find out the factors of 15. So there I can just get 5, 3. 5 rows, 3 columns. Or you can reverse it. That's your choice. Suppose here 3 rows, 5 columns in this way. So you need to adjust entire sequence of number into rows and columns. You cannot give any other. This 5 into 3 is okay, 3 into 5 is okay. You cannot give 2 into 2. You cannot give 6 into 6. That you cannot give. Okay, suppose here, let's say, suppose I'm generating a data with the help of this numpy.arrange function. Suppose here I'm just generating a sequence of 35. Can you give me, if I want to reshape, which factor I can use it? For the reshape, which factors I can use it into the rows and column? Can you suggest me? No, we cannot reverse the order. No, Sandra, no. We cannot reverse the order. Ha, correct. Exactly. Thank you for your responses. Of course, 7 into 5 or reverse also. Both of the things it could be possible, 5 and 7. Right, reverse also, any of the things you can take it. Both of the things are required, right? Means the point is you have to adjust its factors. Whatever the number of sequence we are providing, you have to adjust the factors. Okay, so these are np.arrange reshape functions here. Fine. So just wait here. And the similar way, you can just check it out, the dimensions, shape, item size. And yeah, if you want to check it out, what is the type? What is the type? Suppose here I say, f dot, wait. I want to understand what is the type. What is the type of f? So here it is saying numpy dot nd array, numpy dot multidimensional array. It means f is what? Numpy dot multidimensional array. At the same time, suppose this D is there, I created a D here, this D. So this one is also a numpy array. If I want to find out what is the type of D here, so it is, these are all we are talking about, the numpy dot nd array, numpy dot multidimensional array. These are, okay. So these are multidimensional array. So if I want to store this one in any of the variable, any variable I can take, let's say T is the variable. So T is here. So you can use the same, na? T dot main, T dot max, T dot ending, T dot size, T dot item size. You can just check it out, all these things. T dot D type, that you can do that. At the same time, you can check it out the type. Type means what is the data type? It is showing numpy dot multi-dimensional array. Oh, very good. D type and type D. Very good. Okay, just wait. Let me tell you. Wait. Suppose I'm taking here only. Okay. T is an array. This one is a numpy multidimensional array. Now, I'm writing one more thing. T dot D type. This is integer. Now, be careful, every student here. It is saying, I'm asking here, see, basically, now we are working on numpy array. So T is a numpy array. We are working on numpy array. So here I'm asking, what is the type of T? What is the type? So here it is saying it is numpy multidimensional array. These are multidimensional array. These are 2D arrays. So here it is saying ND array. Now second, here I am asking, what is the data type? Data type. So data type means what is each element data type? Suppose these are the data. What are the data? So here it is saying these are integer. So these are integers and sitting into the memory with 32 bits. So this is the difference between the type T and T dot T type. Everybody is okay up to here? Have you find out the major differences? And up to here, all the things are clear to you? You can just raise hands, that's all. Okay, fine. So all things are clear, thank you. So see the differences. What is the type? What is the D type? Got the point here? See, I'll show you one thing. Just wait. Suppose here I'm creating. Just wait. This is the fruit list. I'm making random list. Wait. How many of you like banana? No. How many of you like mangoes? Everybody like mangoes? Everybody. Oh, so many. So if I'm running it, this is there now. If I want to find out what is the type, see, if I'm writing here, what is the type here? So here it is giving, it is a list data type. This is the list data type. Type is giving, what is the type? It is saying list data type. Here it is giving type T is a numpy array. Hana? If I'm writing here F, suppose here I'm writing DIC, and here I'm giving ID 1, name any XYZ, any. And here I'm giving DIC. So here I'm looking, what is the type? So here it is saying this is a dictionary, fruit list is the list, and type T is a numpy array. This is a type actually. It shows what type of object it is. Up to here, clear? ND is multi-dimensional array. ND is multi-dimensional array. Okay. Now you are having the clear-cut differences between the type, no? How the types are working here. Okay, so fine. So let's move with the T here. Okay. Students, you can see here in NumPy, what we can do, we can give certain zeros also, zeros and ones. So there are predefined zeros and one values provided inside the NumPy. So you can see here, okay, just one more, wait here, see here. Suppose I'm taking any of the data here. See here, suppose B is there, na? B is into the form of two-dimensional data, na? Into the rows and column format. So this B is there, B. Suppose here B dot ravel. There is one of the function, ravel function, which is going to convert 2D into 1D. 2D into 1D, ravel function is going to convert. Is it okay? Ravel function is going to convert this data is coming into two-dimensional array. Na? Now here it is coming into the one-dimensional array. This is a Ravel function. Okay, now see here. In a NumPy array, we are having certain predefined methods inside NumPy array. Suppose here I need entire matrices in NumPy with zeros. So I can be using here np.zeros. So inside zeros, we are just giving 3 rows, 4 columns. Any matrices we can give it. So here it is generating entire data with 3 rows, 4 columns with zeros only. np.ones. Inside the np.ones, I'm just giving 3 rows, 4 columns. So here I'm just giving everything with ones only. Okay, so zeros and ones are being created with the default method inside NP, numpy. Just like right now, I had given arrange functions, which is creating a sequence of integer here. So inside arrange function, there is one more thing. Here, just whenever I'm using the arrange function, np.arrange function. So here I can give some parameters. By default, there are 3 parameters inside this arrange function. Okay. Suppose here I want to give a start. I can give the value for start. I can give the values of end also. So let me give the values of start and end. So suppose here I'm writing np.arrange. And here I want to give start the values from 2 and end the values up to 10. So that I can give it. So np.arrange. Start the value from 2 and end up to 10. So the values are starting from 2 and ending up to 10. 10 means n minus 1. That one is n minus 1 here it is doing. Okay. At the same time, if I'm writing here np.arrange, start the values from, let's say, 11 and end the value up to 21. So here it is starting the value from 11 and ending of the value to 20. This n minus 1 it is going to do. Now here, like I had written that np.arrange function take 3 parameters, start, end, and the last parameter is skip or jump. So here I can use those one. Start the parameter from any value. Suppose that I say start the value from 2 and up to, let's say, 30 and take a jump of 2. So let's see how it is generating the data. Take a jump of 2. So every time the value generated is having a +2. +2 means here start from 2 ending up to 30 and make a jump of 2. So this 2 is a jump or skip. So basically every time +2 is happening and the values are jumping with +2. I had told you that please do not write any of the commands when I was working, because do not code your work simultaneously along with me, because 100% you will be getting error. Once my work is done and the video is uploaded, then you can just watch out the video and you can do the work at your pace. You can just watch out the video, you can stop the video, you can write your commands, and your work will be at your pace. If you start writing all the work here during the class session, surely you are not able to understand number of things you will be skipping, and then you will say, ma'am, we are getting the errors. So please do all this work after the class. Here only you can watch it out how I'm doing. If you are having any doubt, any question, you can ask it and clear your things. Okay. So +2 here, you can do it. Up to here, it is clear now how the start, end, and skip is working. Even you can write here, like if you're writing here np.arrange, that you can do that. Start from 5, end up to 50, and make a jump of 5. So here in this way, you will be getting the data. Okay, and then you can do tree shape accordingly to the numbers we are generating here. Okay, so that you can do that. Up to here, the things are clear to you, how to work with jumping of the data and start and end. Everything is clear. You can just raise hand, that's all. Okay. Thank you. Thank you. You can do easily with the reshape method now. You can do the reshape method whenever you are trying yourself. Find out how many number of elements are there and try to make the factor and give a reshape there. Okay, fine. Now there is a broadcasting in NumPy. Broadcasting in NumPy means we can do certain mathematical operations inside the NumPy. by using each and every element. So NumPy is going to work with each vector with a mathematical operation. So broadcasting in NumPy is basically describing how the NumPy treats arrays with different shapes during the arithmetic operations. These are subject to certain constraints. The smaller arrays broadcast across the larger array so that they can have compatible shape. Broadcasting provides a means of vectorizing array operations. So here we are doing all the array operations and we are vectorizing them. So it means each and every element we can gather, we can make certain mathematical operations inside the broadcasting. So here, if I'm making any operation, so let me see here, suppose I'm writing here A as a NumPy array. I'm just redeclaring A, NP dot array. Suppose here I'm making any array randomly I'm making it here. So 10, 20, 30, 40. 40. Okay. So this one I'm making it here. So A is there. Okay. And now here I'm making a B NumPy array. Again, this one is there. A and B. Okay. Now here now. I can make the multiplication operation. This one is a broadcasting. So how it is working? It is just taking, it is doing vectorizing array operation. Means here, A into B, I want to do it here. So here it is taking the operation such as A is 10 and B is 1. So 10 into 1 is 10. A is 20. B is having a value of 2. So 2 into 20, that is 40. Then 3 into 30 is 90 and 4 into 40 is 160. So basically here it is doing all the operation here with A multiply B. So all the vector in A and B, it is being multiplied inside the NumPy array. Okay, so that is there. Up to here, the things are clear to you? Okay. Up to 2-dimensional array, we are going to work here in this NumPy array. Okay. Now here, suppose I'm going to do here, just wait. Suppose here, A here I'm just putting, just wait here. Here I'm putting A. into okay, right now these values are A into B. Just wait here. Let me suppose this one A values I'm taking. A, suppose here I'm taking the value here. Just wait here. Let me just wait. This one is A array. If I want to make a power of this A, so A into 2. That means into 2. So we are doing a certain mathematical operation with this also. So here we are just taking power A here. It is just making the square. A into 2. So that is 200, 400, 900, and 1600. Okay, so in this way we can do the mathematical operations. Even if you are taking here, suppose I'm having a value of A and B. Even if I want to do the mathematical operation of A plus B, A minus B, simple mathematical operations. So these are all broadcastings in NumPy array. So vector by vector operations are there. Here we are doing the actually here we are doing operations of NumPy array. If you want to take a maths library also, that you can take that, up to the choices. A plus B is basically, we are adding A NumPy array and B NumPy array. Please focus on the class. Okay. Now let's go here that we are here into the NumPy. Now let's read about the this NumPy here. Okay, so here we can see inside the NumPy, there is a random library. There is one of the library, a random library, where we can generate a random number. So whenever we need a random numbers to be generated, so here we can find out with the NumPy library, np.random. From here, there is one of the functions. So it means inside the random library, inside the NumPy, we are having a random library. Inside the NumPy, we are having a random library, and inside the random, we are having a random functions. Okay. So inside the random functions, whenever we are providing any number of rows and columns, so accordingly to that rows and columns, we can generate any random numbers, The random numbers could be any. Okay, so random means any numbers. So np.random, and inside that we can provide any shape. Any shape we can provide it with the rows and column. So correspondingly, a random number will be generated. Okay. So whenever we need any random numbers, we can just generate it, and it could be any numbers in case of random numbers. Now, suppose here I want to generate with the help of NumPy and its function, I want to generate the number ones here. So here I can use one of the functions inside the NumPy. That one is np.ones. So here you can say, suppose I'm generating here np.ones. So np.ones, here it is generating 2 rows, 3 columns. So here also in random numbers, it has generated 2 rows, 3 columns, because here we are having row number 1, row number 2, and column number 1, column number 2, and column number 3. Okay, that we are having it. Now here in np.ones, I'm generating all the ones number with 2 rows, 3 columns. So same number of rows and number of columns we are generating. Okay. And now if I want to do a specific function of addition, so here we are just doing the vector operations inside the NumPy. So here we are just taking this, we are doing mathematical operations on this NumPy here, b plus c. So here we are adding all the NumPy array vector by vector. So it means here 1 plus 0.25, that is 1.25. 1 plus 0.55, that one is 1.55. Okay, that one is there, right? That one is there. So here, if it is like 1 plus 0.96, that one is a 1.96. So these are all basically, we are doing vector operations on NumPy array. Okay, that we are doing it here. So whenever we want to generate a random number, we can use the random function here. Now, there are certain universal functions. Universal functions are just like to find out the square root, power, addition, or if I want to do any exponent. So here, inside the NumPy, there are certain additional functions. We are having here addition function. Right? So here, right? So that one is np.arrange3. So suppose here we are just generating the data with 0, 1, 2. So then here I want to find out the exponent of b. So here it is going to find out exponent of all b. If I want to find out the square root of b, so here it is just find out square root of all b. So these are just using, we are just using inside the NumPy all the universal functions here. Okay. Now here, if I want to take, suppose here I had generated a B data. Inside the B data, certain arrays we had generated 0, 1, 2. And here I had generated one more array. C array I had generated. Okay. So I can use another universal function of add. So here I'm just saying numpy.add B and C. So whatever the data is present inside the B and the C, they are going to be added here. Inside the NumPy, we can have the indexing and the slicing also. Okay. So like here, because whenever we are finding out the sequence of integer. So there we can find out the indexing, slicing, also just like we did it during the list also. So here we are having the np.arrange and all the data we are having. So these data are having default indexes also, default indexes they are having. So if I want to find out certain indexing, that what is the data present at the index 2, suppose at the index 2, what is the data here? So 0, 1, 2, the 2 is the data present at the index 2. We can even do the slicing also, that what is the data present at 2 to 5. So 2 to 5, what is the data present up to 2 to 5 here? 2 to 5 range, that one is 2, 3, 4. So in this way, we can do the indexing, slicing, as well as the negative indexings also we can do that. So positive indexings and the negative indexings are present here. So -1, -2, -3, and -4. So we can find out what is the data as present at this negative indexing as well as positive indexings. You can just check, right? So we can do all this indexing, slicing, we can do it here. So these also we can do it here, that what is the data in like, if we are doing negative slicings also, we can do it here. So here we can see that from -4 to end, what is the data? So from -4 to end, what is the entire data? That is 6, 7, 8, 9. So here it is giving to you. If I want to find out what is the data at -4 to -2 here, so the data point is moving towards the -4, then from here it is going to towards -2 side. -4, -3, and -2 here. So here it is putting the outputs coming down. Right here. Even if I want to find out certain more slicing, so here I can just give any arrange function. We can find out the sequence of integer, and we can find out the slicing, that like what is the data coming from fifth number here. Fifth number here. So here we are just giving the slicing here. Okay, what is the data coming at the fifth number? So 0, 1, 2, it is being arranged here, like here. 0, 1, 2, 3, 4, 5. So from here, the data are taking starting position and the end position up to end. It is taking all the data. So slicing it is going to do. Now, certain time what happens that suppose here we are writing any numpy array. And inside the numpy array, we do not have any values. Suppose here, I'm just writing any numpy array. Let's say I'm having this data. This is the data. So here, suppose I'm having any value, let's say 9.6, 8.4. And this data, this is a, suppose I say missing values I'm having. I do not have any values here. So I will call these data as a missing data. Missing data means unknown values. We do not know what are the values. So here I can just give those values as np.nan. So nan values are missing data. Missing data means no information about the data. So we can just put np.nan values. In a similar way, suppose I'm having any other values, but here I'm having a missing data. So simply I can give np.nan values. So missing data where no informations of the data are present, they are just represented by np.nan. So here we can just fulfill those values with a nan. So whenever we are making a numpy array and our data are missing data entirely, okay. So np.nan, it is there. So there we can give np.nan, numpy.nan means the data are missing. Okay, the data are missing. We do not aware with the data. So simply we cannot put the values 0 or any other data, simply np.nan. It means there's no information about the data, missing data are there. So that we can put it. So automatically numpy array will be taking this value as the nan values. So nan values are basically the missing data are here. Now inside the numpy array, basically just like inside numpy, like there is a random module, and inside the random module, there is one of the function is random, and the function is also a rand function. Both are these similar, random and rand functions, both are similar. The name changes are just due to the versions. In earlier version, it is random. In the newer version, it is rand function. Both are same, which are going to generate the random values. Random values means any values could be generated. And here, there is one more function, rand and function. Rand n means rand normal function. So what does it mean here? That in random, whenever we are using a random or rand functions with certain specific, you can say rows and columns. So there, the values which we are getting, they are coming into the positives only. But whenever we are giving rand n, so here we are getting some of the values in positive side and some of the values in negative side. Okay, so whenever we are using a rand n function, we'll be getting few values into the negative sides also. And in rand function, we'll be getting all the values in positives. These values certain time we use in statistical mode. Hence in future, maybe if I'm going to use it for the statistics. Okay, but here just, this is for the general knowledge here I'm giving, that there is a module numpy.random. Inside that random, there are functions, random, rand, and rand n. Random and rand functions are similar. The name changes are just due to the version. And rand function will be giving certain negative and positive value. And rand n function is going to give certain negative and positive value. And rand function will be giving only positive values. These are very general functions I had told about the NumPy. So this is all about the NumPy. These are the very basic functionalities we have told about the NumPy, that how the NumPy works. Okay, so that is there. Okay. Up to here it is clear now. At least basics of the things are clear to you now. Okay. So let's move ahead now. Okay, so like here, we are having a library. We had covered one of the libraries, NumPy. Now we are having another library. That one is Pandas library. That one is very important library, Pandas library. Okay. So let's go ahead with the Pandas and see what are the benefits related with the Pandas. That are, when we talk about the NumPy, we are dependent on to the numerical values only. Only numerical data we are having. Number data we are having. So here, either I can use the integer values or the float values we are having. Okay. Now here, when we are talking about pandas facilitate us with different types of data. Either I can use here integer data, we can use a float data or a character data here. Okay, so that is there. So integer, float or character data are there. So now let's go ahead with the pandas where we can just specify all these types of data type, because in numerical Python, we are stuck to one type of data, only numerical data. But in case of pandas, we can go ahead with integer, float or the character data. Okay, so that is there. Okay. So here in pandas, we can create in pandas, there's the facilities of creating table-like structure where we can be having certain columns as well as rows. Okay, so inside pandas, we can have certain columns as rows here. So like column number 1, column 2, column 3, column 4. Okay, so that we can create it. So table-like structures we can provide inside the pandas, as well as rows also we can provide it here. Okay. So now inside the pandas, we are having we are having dimensions. So these are the dimensions basically, like rows and columns we are having as a dimensions. So what happens in pandas, that these dimensions which are coming as a rows and columns, these dimensions could be labeled also. They could be labeled also. It means we can provide here labeling. Okay, we can provide the labels also to the columns. And inside pandas, these dimensions, which are rows and columns, they are by default indexed. Okay, by default index means here, like here row number 1, so that one is indexed with 0, 1, 2, 3. And also in pandas, like we are having all the columns here, so they are default indexed. This 0, 1, 2, 3, 4 values and goes on. So it means whenever we are talking about rows and columns in case of pandas, because pandas facilitate us to give the table-like structure two-dimensional data. So here we can have like rows and columns. So they are by default indexed. By default index they are. Okay. And even if we want to give certain label, so here we can give the label. So here I can give ID, name, age in this way. Now here now, suppose here I want to put any data here. So here I can give the values of ID into the integers. We can specify any names, any name it could be. Okay, and any age. Even if we are specifying any other column, suppose as sal column or fees column, let's say we can just take it a fees column here. So that could be also by default indexed. They are by default indexed. Suppose there's a fees column I'm writing in any particular fees column. So here 3 is there. So we can provide the fees into the float data, decimal data also we can provide it. So basically pandas is very important data science library. Pandas is used for data analysis purposes. And here, this library facilitates us to give the table-like structures, and we can use here different data types. Inside pandas, we can use here different data types also. So when we talk about the pandas, inside the pandas, basically, there are two types of data structures inside the pandas. The very first one is the series, and the another one is the data frame. Another one is the data frame here. Okay, so the very first one is the series, and another one is a data frame. In the case of series, this one is a one vector only. The series will be giving one dimension only, one dimensional data only this is provided. And data frames are providing two-dimensional data. So inside data frame, we can write the table-like structure because it provides the facilities to write two-dimensional data. Here we can provide X and Y structure. It means we can provide a table-like structure with the rows and columns. We can provide it inside the data frame. But in series, we can have only one vectors only. So let's go ahead with pandas. And inside the pandas here, we can just wait here. We can write with series, we can write only one dimensional data only single dimensional data. So to do the pandas here, I need to call pandas, import pandas library. Okay. Just wait, it is loading it here. So you can see it here. Pandas is a very important data science library. It is used for data analysis. And these pandas are very fast, powerful, flexible, and easy to use open source data analysis. And they are basically open source data analysis and manipulation tools. That one is built on the top of Python programming language. So here we are going to call import pandas. So when I'm going to call import pandas, so here we can build up the series with pandas, pandas.series, capital S is there. And here I can build up the series of pandas. This one is the series I had built up with a panda. So here, what this series is showing to you, this series is showing to you that this one is a one vector array. And the series elements are auto-indexed. They are auto-indexed. So that's just showing you auto-indexing also, and it's integer data type. What I can do, I can just load here. It's much better to load import pandas as PD. And here I can write, suppose any pandas series I want to build up. So pandas.series here, and then here I can take the value of so this one is a series. If I want to write here B is equal to here I can give any other value. So this one is a series element where we are giving the data in form of this way here. So all the data are coming into the one-dimensional array data, and here all the values are indexed. So default indexings are provided here. 0, 1, 2, 3, 4, 5. So default indexings are providing here. So 0, 1, 2, 3 are these are the index default here. Okay. Suppose here I want to write here C is equal to PD dot just wait series. Here I can give any data. In this way. Now inside Panda series, there is one of the parameter, that one is the index parameter. And if I want to change the values of the indexes, which are coming by default with 0, 1, 2, 3, if I want to change the values of the indexes here, so that could be changed. Suppose here I want to change these indexes to 10, 20, 30, 40. These are the new index value we want to provide it here. So we can provide it here in this way. Okay. So here you can change the values, right? Any other indexings also, suppose here I want to write it here. D is equal to suppose here I'm just putting any value. Okay, so index element, I'm just giving 11, 12, any index values, you can change it. Okay, but all the index values will be similar to the number of elements. Suppose 1, 2, 3, 4, 5. So 5 elements are there. So in this way, these index values are changed. Okay, so let's see. By default, is the data type is integer 64, default integer 64. Okay, so basically, pandas elements, series elements take the data as a 64 bit. So it means that the default it will be taking 8 bytes. So they are default here. So there is one of the parameters, just like we are having in pd.series. The data, this one is the data we are providing. So basically, see what I can write it here. We can write here data is equal to in this way. This one is a data parameter, index parameter if you want to change. Otherwise, it would be a default. Like here, we are working with the default values. So default indexes are there, right? And here, the default index is integer 64. So what I can do here, I can write v type is equal to see here, default it is integer 64. Got the point here? So data, index, d type. These are the default parameters present inside the Panda series. We can change the index if we want to, but if we are not making any values here, okay, so the default values will be captured here. So just like we are doing it here into the index, here we are not keeping any index, so default indexes are working here. Got the point here? So this one is the basic structure of the, this one is a basic structure of the, this element here, just wait here. This one is the basic structure of the Panda series element here. Okay, just see it now. The default values of pandas are 64. Okay, 64 it is. Even into the series elements, suppose here, I want to give here some data with the, just wait. Suppose here I want to give any data. Let's say I'm building up the data. E is equal to PD dot series. Any value here I'm writing. We can give here any float data as well. This is the data here. So here it is taking a float 64, default float 64. So you can give this data. If you want to change here these indexes, you can change these indexes as well. That is your choice. So index values also, you can change it. Okay. The type is default float 64. This was a default float 64 it is taking, yeah. So here, suppose I want to do certain indexing here. So we can find out that what is the element at the 2th index, that is 99.3. What is the element at the 4th index? That one is 28.6 at the 4th index. Okay, that you can do that. If I want to take the data from 0 to 2, so here it is taking the data from 0 to 2. So we can do certain basic slicings also, 0 to 2. So 0, 1. So here it is going to take the data 0 to 1, 0 to 2. So it is going to do the slicing as well as indexing. So also we can do that. Okay. Even we can provide here NumPy array data also have the dictionaries also. So here what we can do, suppose here, I want to give here, let's say, just wait here, let me do one thing. I want to create a NumPy array. Suppose here I'm creating here NumPy array. K is equal to NumPy array. So to make a NumPy array, I need to include NumPy. Okay, so if I want to create a NumPy array, so here I'm just creating, suppose J is equal to empty.array. So this is the J. So if I want to pass this J into the pd.cd, that also we can do that. So here we can pass on the NumPy array in this way. Okay, you can just give any variable name that is just like T. T is a variable name here. So in this way. So you can pass on the NumPy arrays inside the series element. And suppose here, I'm writing here dictionary one. Any data related with the dictionary is also I'm writing. Suppose I have ID. So we can pass on the dictionary values as well. Okay. And even if I'm providing here a list one, inside the list one data I'm providing, any data here I'm providing. So we can provide the list data also inside it. So you can read it now, please. Just check it out, all the commands, just read here. You can read this command, that how we can load the NumPy data as well as dictionary data as well as list data also. Just see it, please. Read it. Read the commands. Up to here, all things are clear now? Okay, thank you. Fine. So now let's come to the pandas data frame. Let's see how the pandas data frames are working here. Okay. So here, basically, when we talk about the pandas data frame is a two-dimensional data structure. Data is aligned in a tabular fashion in rows and columns here. Okay. Right. So here, let's see certain features of the data frame. That one is, we can see here that basically in pandas, we can build up certain columns. They are having different data types. We can increase the column even after creation of the data frame. That's why their sizes are mutable. Mutable means we can change the sizes also even after the creation of pandas data frame. We are having the labeled axis, rows and columns. It means we are having rows and columns, and in rows and columns, we can put certain names to rows and columns as well. We can label them. We can perform certain arithmetic operations on rows and columns. So in pandas, we can do certain arithmetic operations also. Okay. So let's see how to work with the pandas here. So first of all, let's see labeled axis. Labeled axis means here, if we are working with a pandas data frame, we can work with rows and columns here. So we are having like column number 1, column number 2, column number 3 we are having, and we are having a row number 1, row number 2, row number 3, and these could be labeled also. So these are labeled axes. Labeled axis means we are having X and Y data. Okay, so we are having this X1, row number 1, we can just determine it as the X1, X2, X3, and here we can just call it as Y1, Y2, and Y3. So these could be labeled also. So labeled here, we can just give the values of ID, name, age, and further values we can give it. Here we can put out the data. The data could be of any type. Okay, and we can do certain arithmetic operations. So for this, we can just go ahead with the pandas data frame. So if I want to go ahead with the pandas data frame, what I can do for that? So here I can call import capital D it is. Here we can provide any data, simplest data we are providing it here. So this one is the pandas data frame here. Okay, so it is having basically columns. This is a 0th column, and these are the rows. Row 1, row 2, row 3, row 4, and row 4, and this one is a column. Okay, so that we can take it here. Now you can see here, suppose I'm going to take this data. I'm going to build up this data. So this one is a list I had created. And I'm just passing this list inside the data frame. Okay. So if I want to pass this list inside the data frame, let's see the structure, what type of structures we are getting. Here we are getting this types of structure. Okay, so you can see here that we are having a table-like structure now into the form of rows and columns. So this one is a rows and columns here. So these are column number 1, column number 2, okay? And these are row number 1, row number 2, row number 3, right? So basically, these are designated with the indexings. So indexings are here, 0 is given to column number 1, 1 to column number 2. And here 0 is given to row number 1, 1 to row number 2, and 2 to row number 3. So basically, these are indexes. By default, indexes are provided towards the column as well as the rows in case of data frame. Okay, so these are the default one. We don't give it, automatically it comes here. Now suppose here, I'm writing the same one, just wait here. I'm going to take this data. I'm going to take this data I'm going to take it here. Just wait here. Here, suppose we are providing this data, the data variable which I had given to this list. So this one I had provided it here. And here, just wait. There's one of the parameter inside the pandas data frame. That one is a column. And inside the column, suppose here this, I want to put it as name. It is name. And the second column, I want to put it as, let's say, age. I want to put it. And then I want to say this data. So in this way, it will start coming in this way. So you can see it here. We can put a labeled axis. There's a term given as a labeled axis, means here these indexes which are coming here, they are labeled. So here, with the help of columns parameter, we can provide name and age here. So here onto this 0 and 1 index, name and age are provided to these columns. So here, name and age are provided to these columns with a 0 and 1 with the help of columns name. So basically, inside pandas data frame, we can provide the name and age. We can provide the labeled columns, we can provide it. Labeled columns, we can provide it. Okay, that we can do it here. Right? And the default is basically the data type float is there. Okay. So if I want to give here data type float, so my data would be changing into the decimal values. My data would be changing automatically into the decimal value. But by default, it will be taking the data type in integer. Like here it is giving an integer, but if you are giving it forcefully a float data, so all the data will be changing into the decimal values here. Right? So in this way, we can do that. Now here you can see, even I can pass the dictionaries data also. So here you can see, suppose this was a basic list I had created. Suppose I'm just giving here dict1, dictionary 1 here I'm just creating with certain ID and the names here. So ID here I'm just giving it, and here I'm just providing any data here. This one is the data, and here I'm giving it. Any name here I can give it, any name. So if I'm having 5 values here, so correspondingly 5 names you are going to provide it here. So this is the dictionary I created. Done. And here, when I'm giving here, suppose A is a variable, here I'm just going AD dot This one is there. This one is there. So what happens basically inside Pandas data frame, ID and name. ID and name will be coming into, means here whatever key values which we are providing inside the dictionary, and when we are providing that one into the data frame, so those dictionary keys will be acting as a columns automatically. And all the values which we are providing into the list, they are coming as the values. So here into this data frame, these IDs and name, which are working as the key here, they are coming here as a column by default. And this way you can work it. Just wait here. In Pandas data frame, we can provide the index also, and we can rename the indexes values as well. Okay. So you can change the So in Pandas data frame, we can just make the column name changes as well as index values also we can give it. And by default, the values provided here in Pandas data frame, they are default indexed in this way. Default indexed. Okay, so that's all for today. Thank you very much. Thank you.